Hi everyone. Today we're going to look at Boyle's law. Boyle's law is the first of our 5 gas laws that we're going to study in this unit. Boyle's law starts off comparing pressure with volume. So pressure is inversely related to volume. So what this means is if pressure increases, so let's go, if pressure increases, the volume has to do the opposite. It would have to decrease. That's what inversely means. So volume must decrease. Okay, that's the relationship. To visually express this relationship, if we just drew a little beaker, and let's say that there's a lid or piston, okay, so there's a cover at the very top that we can move up and down, okay, and inside the beaker, let's say we have a few molecules of gas. So there's 1, 2, 3, 4, 5, 6, 7, 8. Okay. So let's say there's 8 moles of, let's say, neon gas. Okay, that's placed here. The volume that we're talking about, okay, represented by V, is not the amount. The amount is 8 moles. The volume is how much space that 8 moles of gas takes up. So volume means how much space a gas occupies. Not amount. Okay. If we're talking about amount, we'll refer to the amount in terms of moles. So here, let's say that there's very little pressure being placed on top of this lid or piston. Okay. But if we were to increase the pressure, so let's look at what happens if we had the same beaker, but this time you increase the pressure. The pressure is much larger. Okay. That's going to be represented by us pushing down on that piston. Okay. So if we push down, because there's a lid on top, the number of moles of gas is still the same. There's still 8 moles of neon gas. Okay. But the volume itself is much smaller. It's taking up less space. So when pressure increases, volume decreases. The space is smaller. But with the same amount of gas. Okay. So what we're saying here is the amount of gas has to be constant. Another thing that has to be constant too is the temperature. So in both these scenarios here, temperature is going to be, let's say, 20 degrees, room temperature. Because later on you'll realize that if temperature changes, that's going to affect volume as well. So if temperature is the same and the amount of moles doesn't change, everything else is constant, then we can use Boyle's law, which can be represented in a formula. So the formula, which is what we refer to as a gas law, okay, so the formula or law is P1 times V1 equals P2 times V2. Okay. So if we look at our original diagram again, this is P1, this is V1. After we've changed everything, there's a new pressure, so that's P2, with a new volume, V2. And this can only be used if moles and temperature is constant. Okay. So let's look at a really quick example. Example 1. If P1 equals 101.3 kPa, V1 is 50 liters, P2, let's say, has increased to 325 kPa, then what is V2 going to be equal to? Okay, so we're trying to find V2, so we're going to have to isolate it. V2 by itself can exist if you take P1, V1 divided by P2. So we're just rearranging the formula. And once we've rearranged, we just substitute our values. So 101.3 kPa times a volume of 50 liters over the new pressure of 325 kPa. You'll notice that kPa cancels out. All you're left with is liters. So V2 is going to be equal to 15.58 liters. Okay, this is how much space it occupies. We don't actually have 15.58 liters of gas. Okay. If we wanted to know the amount of gas, we actually have to find moles. Okay. And that will occur later on in this unit. But for now, this is a very, very simple relationship, okay, where we can just easily manipulate the formula to find what our unknown value would be. In the next video, we'll take a look at a slightly more complicated formula. Well, sorry, correction. Not formula, but we'll look at some more complicated units, okay, that we have to deal with first before we can apply Boyle's law.